This morning, we talked about per pixel and table models and a little bit about auto ML models. And now we're going to move on to the next thing, which is generating training data for a larger training data set. So this is where you might want to use some of the new compute pixels methods, and specifically Apache Beam is what we're going to show you here. So the thing I want to point out here is that the afternoon's festivities are split into 4 different notebooks. So this first notebook is generating training data locally, meaning running Beam in the Colab VM, which may or may not be heavy duty enough for what you're trying to do. Genna's going to tell you about scaling that Beam pipeline using Dataflow. Then we'll do training on Vertex AI and hosting to get predictions. And at each step of the way here, this training data takes a long time. So we're not going to be able to finish this here. But I've already pre-generated the training data, so we should be able to use this notebook directly. And the model training takes too long as well, but I already saved the trained model, so then we can use that trained model in the last one. So that's why I have this split up like this. Okay, so all those links should now work because we just fixed them. And now we're going to move on to part 2. So for those folks who are new to the session, this is the link to the slides. It is also on that whiteboard right there. You are going to need that link because everything that we're doing in here is going to come from these slides. Okay, what's new? Previously, I mentioned that we had this 1D vector in and 1D vector out thing. And now we want to have essentially 3D vectors in and 3D vectors out. Meaning that instead of just a pixel going in, there's going to be a whole patch going to the model. And then there's going to be a whole patch coming out. And that's called a fully convolutional neural network. Note that a patch is, a huge amount of data. This is where built-in classifiers to Earth Engine are going to start breaking down. In other words, if you've got some very, very large number of input features or their input patches, you're going to have to go to TensorFlow instead of using the Earth Engine built-in classifiers. I think that's still a true statement. Questions about this? Okay, so this is what we're going to try to do. We're going to try to make a land cover map. So as I said previously, this is kind of like dynamic world light. So the idea here is that we're going to use patches to classify land cover. And that's somewhat like a dynamic world, but much less fancy. Okay, just sort of some background here. I just picked these regions in an interesting area and said, sample a bunch of points from inside there. And so what we're using for training data is an existing land cover data set. So we're not having like user labels or a ground data or anything like that. We're just going to use an existing product as sort of a demonstration of how you do it. If you want to see where these training data came from, feel free to check this script in the bottom here. Okay, what happens if I go to this notebook? It loads. That's very good. As I said previously, you need to be able to set up a cloud project to follow along with this demo, and it has to have billing enabled so you can use cloud storage and so on and so forth. If you want to do that, feel free. If not, that's okay. Just follow along or watch your neighbor. Okay, let me make this bigger in the back. Is that okay? Is that legible? Okay. So the first thing that we're going to do here is install Apache Beam GCP. It's not enough to just install regular old Apache Beam because we want to have these custom syncs that go to cloud storage and stuff. So you need to install the Apache Beam for Google Cloud Platform. And once that's done, it's going to make you restart the VM. And so you just click restart, and yeah, that's okay. So now we should have the Apache Beam library installed into this VM. After running it, I got this helpful message when I was reading datasets, which said, couldn't find Python snappy, so the implementation is not quite as fast as it could be. So yeah, sure, why not? Let's install Python snappy as well. And once we've done all that, we should be able to just import this stuff, and away we go. So these are all just imports. Note that I am sort of printing out these versions. Occasionally, version mismatch becomes a problem, and so it's nice to just sort of get a reality check on the versions that you're using here. Okay, so now is where you have to enter your project. So I'm going to use the Earth Outreach project again, and I can't remember if I deleted my bucket or not. Let's see if I did. So go to the console, the Cloud Console. Just out of curiosity, how many folks are going to try to follow along here? All right, so a good number here. What did I do wrong here? I forgot something. Okay, so here's my Earth Outreach project, and let's just go to cloud storage, and oh good, my bucket is still there. So I'm just gonna reuse this bucket. It's kind of a silly name at this point, but that's okay. All right, so this goes into my bucket. Now I've got the project set up, I've got my bucket set up, and we're doing the same trick that we did before, which is authenticate to Cloud Platform and then reuse the credentials for Earth Engine. And again, we're specifying that project, and we're specifying the Earth Engine high volume API for the endpoint, because we're going to be making automated requests. And so you want to be connected to the high volume API if you're doing that. Okay, variables. This is just some information about where to put the map and the size of the patches and stuff like that. Specifically, we're going to be collecting 128 by 128 patches at 10 meters resolution from the Sentinel-2 dataset. Also, we are going to be using this request template to make our requests. And so this will become more obvious later, but the basic idea is that you can get a variety of formats directly from the client using compute pixels. Here we're going to get NumPy arrays, but you can also get GeoTIFFs and JPEGs and other image formats and stuff like that. And we'll populate this request sort of when we come to each point and do the sample. Okay, so what's going to happen is we're going to try to take a stratified sample with 64 points per class in each one of those polygons that I showed you previously. So that's the idea here. And this is just a hard coding of those polygons that I was showing you before. Again, see that script if you want to know more. There's a list of them. These are the input bands that we want. These are Sentinel-2 bands. Again, we have an output band called land cover. And then we create an input dictionary that we use to parse the features. But now our fixed length features are different. These are not 1 by 1 by 1 features. These are, 1 by 1 features. These are patch size by patch size features. So that's somewhat different than what we were doing this morning. Okay, so the classification data set, this is just the representation of the classification system that we're going to be using. Dynamic world, this is just for comparison, but that's what dynamic world looks like. It's pretty amazing. Does anybody in here use Dynamic World for their research? Or yeah, a few? Okay, check it out. So we'd like to sort of replicate this if we can using our model. And here's the Sentinel-2 data that we're going to use. This is just a sort of a, not fancy semi-cloud-free composite. If you want a fancy cloud-free composite, go to the CloudScore Plus presentation this afternoon at 4 o'clock, I think. It's at 4. It's at what? 2:30. So right after this. Okay. So this is our sort of cloud-free composite. World cover is where we're going to get our labels. So we're going to stack all the Sentinel-2 data, and we're going to have a layer of the labels, and we're just going to take chunks out of that stack there. And so this is what that map looks like that we're going to use as our sort of ground truth or reference labels. Okay, and then just display the legend again. Okay, now generating the training data. First of all, note that there is a stratified sample in here. And once we get that stratified sample, so again, roughly 64 points per class, if we can, if there are so many points. And once we get that sample, we're going to turn it into a list. We're going to turn it into a client-side list, meaning that I'm asking for that list of sample locations onto this machine. So getInfo is going to, actually make a request to Earth Engine to get that list. And then that means that I can iterate through it on this client and yield those coordinates one at a time. And you'll see where that comes into play in a second. Okay, so say you've got a point, and now you want to get a patch. Basically, you get the composite. Here's that request template that I showed you before. And we're just going to set the expression to the computed image. So this image is a computed thing. This is a server-side computed image. And then we just move the location of the patch into the upper left corner from the center. So that's what this stuff is doing. And then here's where the magic happens. You call ee.data compute pixels with that request in it, and what you get back is a NumPy array. So this is very different than export, where it's all sort of doing something on the server side. Here you're getting that NumPy array right to wherever you're running this code. So we just want to get those functions ready here. And now we can test this by just getting the sample and sort of, inspecting one of these coordinates here. So there's our patch. It's 128 by 128 with 13 bands, and these are the data types of it. So all that looks good. And we can also have a look at the patch to make sure there it is. And then we can have a look at the numbers. Do they look reasonable? Are there nans or other weird garbage in here? And then look at the classification. The same. So this patch, these are the labels that go with this patch up here. And we can look at that in the slide. So make sure that all that stuff matches. Okay. So we checked one patch. Now we get to the fun part, which is Apache Beam. We need to write a special function at the end that will take our NumPy patch and serialize it into a tensor proto. So that's what's going to happen here, and we want to serialize those things into tensor protos so that we can write them into a TF record file. And all that is going to happen inside this Apache Beam pipeline. So specifically, and I'm no Beam expert, so if there are Beam experts in the room, please help me out if I get into trouble here, including Gunna. But the basic idea here is that you start with those regions. You start with those set of regions, and then in each region, you take that stratified sample by land cover class, and that'll yield some largish number of points per region. And then you do a flat map over that to call that sampling function. So what's happening is you go to each region, you take the stratified sample, you generate the list of coordinates, and then you start sort of iterating over those coordinates, requesting a patch for each one. And here's requesting the patch. Here's serializing the patch. So you get a NumPy array, you serialize it, you split it into two pieces, training and validation, and finally you send those sets of points to this output sink right to TF record, which can write directly into cloud storage because we installed the GCP version of Apache Beam. Questions about that?
Two questions. First thing, I've never used Beam. So is it Beam doing parallel computing here? First question. Second is, can you give a high-level overview why using a dynamic world?
Oh, yeah. Okay, so first of all, yes, it is parallelizing things, and that parallelization is more or less efficient depending on the pipeline options that you give it and where you're running it. So here, we're running it on the Colab VM, which is pretty wimpy for this purpose, and so we're probably not getting a lot of parallelization. Genna's going to tell you how to really crank that up in a second here. Dynamic world. The only reason I'm using it is because I wanted to see it. Because I wanted to have a look at the distribution of things and sort of use that as a reference for how good my model was doing. So you could use those labels for training instead. I just chose world cover, just for fun.
Why are you serializing it? What if we speak to serialize?
Yeah, you could just store it as something else if you want. I find these TF record files to be convenient and performant, so that's what I went with, but you could write something else if you prefer. Okay. That's the end of this notebook. It's running. And it can run for quite some time here. This is probably not the way you want to do it in production. It's worth noting that our docs demonstrate a different way using Python concurrency and just futures library. So you can just see our example docs if you want to just use Python concurrency to do it. This is the Beam way. The advantage of doing it the Beam way is that then you can scale it on Dataflow if you want. You want to take over?
Sure.
Okay. Okay, so where did we get to? Those are the things. We went to the notebook. We stratified sample. We got the training patch. We examined it. We serialized it into TF train example protos. We ran the pipeline. It was too slow, so now we asked Genna to show us the fast way.
Thanks, Nick. So let's see if it's still running. Yes, it's running.
That one is probably going to run for the entire time that we're here.
Yeah.
So you can just ignore that.
I actually realized now that in the Data Beam version, I did not split. I just wrote in TensorFlow. But these are like small details. So let's have a look what we have here. Actually, about Apache Beam and Dataflow. So did any one of you work with Apache Beam? So hands, 1, 2, 3, 4. Yes, cool. So Apache Beam is, and Dataflow, these are indeed libraries, services. So Dataflow is a service in Google Cloud, which can run Apache Beam pipelines. And Apache Beam, it's an open source library to basically define pipelines which would require a lot of time to run. And then depending on where you run this Apache Beam pipelines, it would run them efficiently. And by efficiently, for example, in case of Dataflow, it would auto-scale and it would decide by itself how many machines it needs to run this specific processing. It will auto-scale up and will scale down at the end. So it's basically the kind of nice way to run very, let's say, the long-running pipelines. It's like, how can I create Earth Engine? Or so that's, you could think of using this system for this type of tasks. So when you have really large tasks which need to scale. And if you look at what's happening there, in fact, Apache Beam or Dataflow can run in like 2 different modes. So there's a batch mode and stream mode. So what we're using here is more batch mode. But once you define your pipelines and deploy in Dataflow, then if it would be stream mode, then you would have maybe very complex processing, which would convert videos and images and do all kind of stuff. And then it would just stay there. Once you could tune it that when data comes in, for example, in storage bucket, it will automatically go over pipeline and would do some processing and will produce some results. So it's really very useful tool or service, but it takes some time really to start using it. This is the icon of the Dataflow. And there are like multiple ways, steps you can do. So what Nick showed in the pipeline in steps, they're actually in different steps. First step was like take regions, but then after that it would just generate maybe, I don't know, 10,000, 100,000 points. And then maybe you don't want to run this every processing of every point on every separate machine. You could tune, so you have in a Apache Beam, you have different operations where you can say, oh, I want to, for example, reshuffle my 100,000 points into like number of buckets, say 20 or 100. This is also the way to implicitly kind of tune Apache Beam or Dataflow actually to tell it, okay, auto scale, but not to more than this number of machines. So it's but there are also parameters you will have available in Dataflow that you can specify how many workers you want to have initially. So there's really, it's out of scope of this session to give full introduction in the Dataflow and Apache Beam. But what we will try to do here is basically take the same pipeline which is still running and try to run it with Dataflow. And I will see if it will work. So what to follow along, what you need to do is click on this Dataflow demo notebook. And then let me just walk you through this notebook and see what's happening here. So the first step is we're doing exactly the same what Nick showed before. So we're installing Apache Beam. We're installing Python Snappy because Apache Beam complains about Python Snappy, so we install it. Then we have something different here than compared to previous notebook. So what we're doing in the next 2 cells is we write in 2 files that will be used to actually script this, to embed all this pipeline, but also to define requirements that we would need to pass to Dataflow. Say, okay, on every worker, once you will be spinning off and running this pipeline, this is what you need, packages that you need to install before you actually run this on the worker. And we use this write file magic called here to basically, when we will, to tell Colab to basically write these files on the file system. So let's wait until this Snappy installs. Okay, so once I hit run here, you see that it generates this requirements txt file. And what we have in the next cell is almost exactly the same script what Nick prepared or showed, except that it's Dataflowified. What I realized, and this is we just sharing now our experiences also while building these pipelines. So what I realized that what we had in this pipeline, here we use regions as a starting point. And regions is Earth Engine object. And while it still runs here and it doesn't crash, if we would pass this the same way, this pipeline to Dataflow, we will start getting very strange errors. So I had to rework this pipeline to make it work with in Dataflow. And what I realized that we actually cannot pass Earth Engine object between these different steps of the pipeline. So when you design this pipeline, different tasks, functions, make sure that what's coming out of function and what's coming in the function is always like simple objects. It could be strings, it could be arrays of strings or arrays of values, but it should not be arrays of Earth Engine objects, for example, because then you will start getting very interesting warnings and errors, and nothing will work. So that's for that reason what I did here. If I scroll down in this script, Dataflow script to the pipeline section, we will see that here, as a starting point, I had like beam create range 8. It's just 8 numbers. And then next step, it would sample polygons, but it would use this index of region actually to pick up region from Earth Engine. So basically you encapsulate all knowledge of Earth Engine in these different steps. And there are also some other things added, like you see here, reshuffle num buckets 20, and which basically do what I mentioned before, that they would make sure that if you have many, many objects, that they would just be grouped into only 20 buckets. And that would tell implicitly to Dataflow that it needs to spin off not more than 20 machines. Let me see if I can run this. So we wrote these 2 files, so that's worked. Then we get to imports. So what we did before, it's just installing packages, writing files, preparing, and we have to re-authenticate one more time. I did not test it on this account, so I hope that something works or it will not crash. Okay, so we still need project name, bucket name, and we need here something else what's called service account email, because that's what we will use in the next step. So let's see if we can get this out of Google Cloud. So
to make a service account.
I think there should be default service account.
Oh,
I hope.
Okay.
I hope.
Let's find out. So the important thing to note about this is that he just took all the code, or the code that we were running before with some small modifications and packaged it into these files. And then you send the files to the Dataflow service, and it loads up all the code and starts running what you asked it to do. And while it's doing that, all this shuffling and these other functions are designed to help Dataflow do load balancing over the workers so that it will be fast. And it's worth noting that there's some real magic in this stuff, and so we're trying to give you some of the tricks here, but there's a whole try Earth Outreach again. Yep. There's we're just scratching the surface here. There's a lot more that you can do with Dataflow stuff.
I just picked up one of service accounts. I hope this will work.
Try it.
The challenge there, what we found is that when you want to script all the steps to make sure that you actually don't need to do it manually in a console, when you use these multiple services, I realized that they actually need to enable some permissions and enable some services. And you could do it, just hit error when running this pipeline and go to console and start kind of configuring, enabling the services, but it's of course much more convenient if you can do it directly in the script. Yes?
I have a question for the service account. Is something that we have to create, or is automated created based on the bucket?
Yeah, so when you create project, under project there's IAM section and service accounts. Normally there would be like default service account. And to be honest, this is what I copy pasted now email. I think there should be a way to just query it automatically using API in Python. We just did not have time to So we were a bit lazy, copy-pasted. But normally you would have default service account for like App Engine or for a project as well. And then you could use that account. And then what will happen next, why the service account is needed, because the next steps are that you would need to enable different permissions to make sure that workers will be able, for example, to run different services or to add roles to these worker machines. Because what happens is when we run this pipeline on Dataflow, it will still run the same Python code, which does request to Earth Engine. And we realize that in Dataflow, we actually need to configure it separately. So you'd have to add these different roles. And that's what I found identified which roles we actually need to make this sure that this pipeline runs smoothly. And you see that this step to, for example, enable Dataflow, it takes some time, because what's happening is that Dataflow, it actually gives you access to the whole infrastructure. So it's similar like to Kubernetes or other engines that you could spin off. It spins off cluster basically for you to make sure that you can run these complex tasks. Let's hope that this finishes as well. And again, these steps take some time here. You see that it's not instant, but some of the steps you would have to do only once. And the same is also true for running pipeline. So once you run pipeline on Dataflow, it will take some minutes before it really starts auto-scaling, scaling up, and running machines. So that's like some overhead. But if your pipelines runs maybe a few hours, so if you have really global export, like if you would need to reproduce something like dynamic vault with, I'm not sure how many, 28,000 patches or locations with many, maybe millions of exports, this Dataflow would allow you maybe to take something that would run maybe for 1 year and reduce this to running in 1 day. So that's kind of type of tasks let's say, where you would need tools like Dataflow. Okay, so then next thing what we need is create a bucket. And this would be so I named here, it also defines this parameter of the name of the storage bucket where Dataflow would store results once it runs in Google Cloud. And this is the only then next lines that you would need to run to kick off this Dataflow or start this service with the script which we provided before. So you can see that we pass as parameter, we just run this main, let's say, script, so main py. There, let me scroll back to the script itself. Oh yeah, I learned here from Nick also that when we write the script to file, then you see that it's like syntax highlighting disappears. So it's, I would expect that Collab should have this by default.
Pro tip.
You could comment out this line, and then you will be back to every nice syntax highlighting where you could basically improve your code. What you can see here, what we added at the end of the script is basically the main function where we basically define this pipeline and would run this pipeline defined here as a function, again as Apache Beam. So what happens, or what Dataflow requires, is that this is how your Python script should look like. And there are like few parameters, arguments added here, like machine type and some other things where you would have to look up in documentation to check documentation on the exact parameters that you would need there. And hopefully, let's just hit run here and see if we get any errors. So here we specify like multiple arguments, check documentation on Dataflow, which exact arguments you can use and how you can tweak and control this. So what can you control there? But what's important ones here, we have specified storage bucket. We specify what runner we should use here. So in this case, Dataflow runner. And then a bunch of other arguments which are like we saw before. Plus requirements file, which then Dataflow would use to configure machines. And you can see that it's started copying, preparing actually the data for the worker, so we don't have anything running yet. Now, what I will do is let me go back to console and check if we can see something in the Dataflow service there. So let's try search here, Dataflow. So yeah, you can scroll and find Dataflow. I have no idea where it is.
It's down there somewhere.
It's somewhere under multiple processing, where you have Dataproc and Kubernetes probably. But you could just search here, and that's one way to find it. So if we look at what we have here, we have jobs and pipelines and workbench and multiple things. Fix missing steps, enable data, okay. I think this pipelines API and scheduler, that's probably the way where you could run this pipelines regularly. So I just make sure that we don't get any errors in our script. I don't see anything here yet.
Must be still trying to create the job or something.
I think in background, it's so what happens is also it tries to prepare, so it takes an image and pushes our requirements file into storage bucket first, but then it tries to actually create image from scratch. And this is normally if you would want to run these pipelines multiple times for debugging, and your script won't change much, it makes sense to create custom Docker image. And then instead of passing script with requirements, pass just Docker image to this runner, then it would take really almost instantly, it will start going into workers. But right now, it really takes some time, and I hope that we will not end up just waiting for both scripts to run.
Neither of these are going to finish.
Yeah, so
we're just
we will check at the end.
But it's like a cooking show, where you like do all the stuff, and then you're like, yeah, but I already baked the cake before, and you just pull it out of the oven. That's what we're going to do right now.
Yes.
We're going to pull our baked cake out of the oven.
So once it finishes, we will have this kind of screens that we will be able to explore in the. Oh, sorry. I'm trying to see if I can zoom in. No. Okay. So sorry for the. I hope that you could see at least this. Different steps. So what you will see once this pipeline runs on a Dataflow is that once it starts running, then you will see like different steps. And these are actually steps what you have in Apache Beam. And once it will be running, you will see actually progress updated in this step. So basically, we see visualize your pipelines how in the ways that you specified in the Dataflow. And then there are also some important, let's say, properties can be shown here on the right. This is once your pipeline will be running Apache Beam, it will automatically auto-scale. So you can see how many machines, in this case CPU, so to run this pipeline, it took 104 CPUs with total memory of 832 gigabytes. So that's the cluster that it was able to spin off, run this pipeline, and then finally you see that like the wall times that it took to run to get patches, took about 10 hours. But in fact, this pipeline, it's run, I think, in 10 minutes or 15 minutes.
17 minutes and 58
Oh, yeah,
seconds.
17 minutes. That's total with like setting up all workers and deploying everything, which takes probably like 5 minutes. And then once it starts running pipeline, then serializing data, it took just 9 minutes. While getting patches, that's where the most of the work was happening. Actually, it was happening on Earth Engine side and not in Apache Beam. So that if you would not use Dataflow, it would take 10 hours. Instead of 10 hours, you reduced it to 17 minutes. A few more things, important things to show here is that once you inspecting these pipelines, this view, it's one you could use, but you can go also to table view, and then you will get more information about, let's say, steps, so you can inspect, get more detailed information. This type of views, they are very useful to really debug your pipeline, see where you have bottlenecks, and really design something which runs faster. As well as jumping into like job metrics, you will see let's say, how much CPU was utilized on every worker or how much memory was used. So maybe you don't need this large machine, or once you start getting errors, maybe you would need machine with more memory. So these are like all very useful views we have there in the services, and as well as scaling up and scaling down of your, let's say, run. So all these charts, all statistics will be available for every pipeline. And for this specific pipeline, it took Dataflow cost $1.4 for 105 machines. It's not that expensive. And maybe last thing to mention here before I give over to Nick is that looking at once you start getting errors, and you will 100% start getting errors once you will run these pipelines. I realized that like looking at the errors in the job log, I could not understand why I'm actually things not working. Then I learned that there's actually a separate tab called worker log. And in the worker log, sometimes you get more errors, which are very informative, but you don't see them on the top, like the Dataflow log. So this is one hint to share. And in general, like observing what Nick already showed, the API calls from Earth Engine or whatever service you use in your pipeline, it's good to always look at, let's say, how much it scales, how many calls do you get per second, in this case, to Earth Engine. So you see that it was able to scale to 20 calls per second to Earth Engine to get images. But also looking at like errors, how many errors do I get? So here I was actually hitting the concurrence rate exceeded, because 20 concurrent calls, that's standard default limit what we have on Earth Engine calls in, I believe, in high volume and both endpoints. And this is what you will, once you hit in this, it makes sense maybe to reduce a little bit by one, for example, your number of buckets, then it would auto-scale till 19 and will not be hitting these errors anymore. And at the end, the pipeline will run more efficiently. So let me do last check to see if you get anything. I think I'm getting errors, Nick.
What does it say? It had something at the end there, at the very end.
Oh no, I think it's getting errors from the not sign up for Earth Engine. Okay.
That'll do it every time.
Okay. I think I will stop here, and then we will.
It's onerous.
So our project is not allowed to use Earth Engine. That's what we got.
It might not be enabled. Check, see if the Earth Engine API is enabled.
I think Earth Engine API is enabled, but what happened is that this project is not registered for Earth Engine. So let's just.
It worked for me.
Register.
You get an error? Oh, it's working? Okay.
So I will just do this. Choose existing cloud project. What was the name of the project?
Earth Outreach.
Outreach. Confirm. And for this purpose, I used a trainee account because that's what we are doing here. And I hope that before Nick finishes his next
right. Maybe it'll recover or something.
Run.
It's okay. All right.
Any questions to this section? Yes?
Yeah, so first of all, amazing work. A lot of information in a single collab. So my question is, can you give me an example of an Artisan application where I'll be using streaming data in Apache?
I can imagine that you would have, for example, you have weather forecast, which you need to update. No, that's maybe not the best, but imagine any application where you would get data put in storage bucket somewhere about location or about, any type of information, image from coming from drone. Once it's uploaded, it's in storage bucket, then you can define streaming type of pipelines that would be observing and listening to storage bucket and get like, I think it's a pub/sub based, so it will get information that, oh, there's new file appeared. Then it will start doing some processing, will run query Earth Engine to get maybe recent data, recent satellite imagery, will do some updates, and will push data into some dashboards or will send alerts to someone. So that would be example where you would have really multiple steps involving more, let's say, intense compute and which would require really scaling. Then I would start looking into Dataflow. Like for simple tasks, maybe just doing cloud function with scheduler would be enough. But when you would need to really to scale and run something which takes 100 hours within 1 minute or 10 minutes, that would be, let's say, where I would start looking into streaming. Thank you. Great question. Okay.
Yeah, so the basic idea is that if you start getting timeouts or errors, if you're doing it the Colab way or you're running it somewhere else and it's just taking too long, that's when you want to consider Dataflow. If you tried to do this as an export, you'd be sad. So this is, if your exports start failing 100%, that's when you want to start thinking about using these alternate methods. Okay, in the meantime, we've already baked the cake and put it into some files in that EE-docs demos directory. And now okay, so Colab says no. No, you cannot.
We need to buy Colab Pro, Nick.
No, I don't think we can. Anyway, so this is an easy fix. First of all, the Dataflow pipeline's already running, so I don't think we need this notebook anymore. We can kill it. Too late. And we can also kill this. I think we're done with this too. I'm just gonna kill this one. We don't need it. So let's see if that's enough here. Okay. So now we're going to do almost exactly the same thing that Genna just showed you, which is to write these files. And the file is a set of instructions that you're going to then send to Cloud Platform to run a thing for you on the server. And so to do that, the same way we needed Beam, we need Google Cloud AI Platform. And then you got to restart the thing. And once you've done that, you should be able to start filling in the variables here. So Earth Outreach is the project, and the bucket was G4G demo. I forgot. What's it called?
And then one.
G4D demo dash neural network 1. That's the one that we killed. That's some other one. Neural networks 1. Okay. So now we should be able to import this stuff and authenticate the same way that you're used to doing here. Yes. Allow. Okay, now. Same thing as before. This is just sort of local directory management here. Here's the file. So we're using this write file magic command that will, put whatever's in this cell, write it into a file on the notebook VM. And pro tip, you can comment this and get syntax highlighting, and then just run this cell to test things. So for example, I've got a bunch of test code down in the bottom here, which we can comment the part that we really want to run, which is this stuff, and uncomment our test code here, and then just run the cell with that first line commented, and then hopefully we should be able to check that we're able to sort of read the inputs and ensure that the code that we have in our pipeline, or not pipeline file, our training file is going to run here. So here I just sort of got some data, printed it out, got a model, printed a summary, all that looks good. So now I'm going to comment this stuff. Done with that. This is the stuff that I really want. This is where you want to do your work on Vertex AI. You want to, model fit is the main thing that you want to happen on Vertex AI, and then you save the result of that in whatever directory you want, and that's it. So here's our big model. Your fancy model goes in there. I'm just going to comment this thing out again. So now it's just going to write that to a file, and that's it. It's just written this little file into the notebook VM, and then we're going to send that file to Vertex AI to create a training job, in theory. Yeah. So I gave it a bucket name of your bucket, which doesn't work. So what you're supposed to do here is give it a correct bucket name, which is in our little file here. So basically, right, so I forgot to do this. I'll just uncomment this so you can see. I forgot to choose something meaningful here. Hopefully nobody actually registered a project with this name, and I just ran some job on somebody's your project.
Just in case that everything runs smoothly during demo.
Demo, NN1, I think, is what it was. And, you can have a folder if you want. I don't think we need a folder here, actually, so I'm just going to take that away. I'll keep some logs just in case. All right, that looks good. Again, this stuff is pre-generated in a public bucket. So we're not relying on the data that we're generating right now. We already did this.
And again,
so
there is a link to, if you would want to reproduce, generate this data, you would find link the same as in previous demo in slide deck, I believe.
Okay, so hopefully we got that fixed up. Let's see what happens here. Yeah, somehow this seems to happen to me. It you have to reinitialize it or something. So basically it's still finding my old your bucket thing, and I'm not sure why. Let's see if we can dig that out here. Oh, so the other thing you can do is just check what's going on the cloud platform here. So what do we want? Vertex. So sometimes you'll find, let's just to see here if there's any training going on. Yeah, see, it's started this thing already or something. I'm going to try to kill it and start over. Delete. And there might even be a code package that it's uploaded into cloud storage here. We can clean that thing out too. So I don't think we need this. I'm going to delete that. Let's just try it again. Nope. Oh, I think I just quick clicked it there. There we go. Oh, there we don't go. Okay, it's still got your bucket.
Can you try resetting notebook?
Yeah.
Maybe search for your bucket.
This has happened before. Sorry, folks. Let me just see if I can get this fixed here. Just delete that.
Delete bucket.
Delete bucket. Yeah, let's get rid of that. This ran yesterday, I swear. All right. Vertex AI. Training. Okay, that's good. Now, is there a your bucket in here somewhere still?
Search.
Yes, there is. I heard a yes.
We're getting a exceeded quota bucket.
Sorry?
We're getting a
Exceeded quota. That's good. That's working.
Yeah.
Okay, I hope I can get to that error in a second. Hang on a second. I don't know, folks. Sorry about this. This is not a new problem, but I'm not sure what solves it other than, running it a bunch of times and...
Maybe restart notebook. Nick.
Well, it did. It overwrote it here.
Nick, if you restart...
Restart the whole thing, I think?
Yeah, go to the runtime, restart runtime. Just trying. It might keep something in memory in Python.
All right, let's just sort of
You see that the difference in this way of working with Vertex AI. In previous example, first session, then Nick used a more command line interface, so like G-Cloud. But you actually can work in alternative ways, just import Python package and just use Python package. And then you will be able to run the same things, but sometimes Python then would just keep some state in memory, so it won't. It's not meant to run 5 times, 10 times.
Yeah, okay, good. Yay, I got a different error. Okay. All right, so this is the error that I wanted to get, which is training failed with the following quota metrics exceeded quota limits, GPUs. So I was pretty bummed when I saw this, but there's an easy solution, which is to take away your accelerator and to specify the CPU image rather than the GPU image. So let's see if this works.
And about that error, this is like standard, some quota limit on every project that you have. So you could request also extra quota, but GPUs are more rare than CPUs. So it might be that in some regions you will not have enough GPUs available, depending on which tasks are running there. And so that's why there is some kind of quota thresholds put by default.
Okay, so that's running. My point was that depending on your project configuration and your org configuration, you may or not be able to use those kind of machines or GPUs. You got to just check your quotas and do it accordingly. We already covered all this. This is just code that we put into that little file. You just have to know where to get the file name, and then you have some parsing code in there. You put the fancy model in there, and then you train it wherever you want. We did the Colab one this morning. We just did the Vertex one. And there are other options, including your big fancy machine that you can just, train it there. Questions? Yes.
So now I have a new error.
Okay.
It's about the bucket. That my bucket location is in US, while the server location is different. So the question is, can we change the location of bucket if needed? No.
Yeah. So we talked about that a little bit this morning. If the location of the bucket is different from the location of where the service is running, you're going to get that error. And that's why I say do everything in US Central 1, or your bucket of or your region of choice, and that will make that go away. So if you chose like a multi-region bucket, that's why that's happening.
Just to be sure, when you say service location, what do you mean by that? Like the location of the data, or I'm not familiar with the terminology?
Yeah, I'm not sure I am either. There are data centers located all over the world, and your data gets, replicated within there, but, only to the extent that you want it to. So if it's like a multi-region thing, that's more expensive, but your data is more accessible to different places, whereas if you just keep it in one place, it's a little cheaper. Genna, maybe you have something to add there.
Right. Like by default, it's multi-region to make sure that your application, if you build in something that where you want data accessible everywhere, it makes sense to have multi-region. Because then like local users would be just getting data from local buckets. And its storage would automatically replicate it, which takes time and resources. So it's always better if you focusing on debugging or you just running this type of background task, collocate your data with your compute.
Okay, too many sessions. So I'm going to kill off one of these. Which one should I kill? Hint, it's this one. And the reason I say that is because that training pipeline's already running. Oh wait, no, I'm sorry. It's this one. The training pipeline's already running on Vertex, and we can go to the console and monitor it and see what it's doing, and so on and so forth. I don't need this notebook anymore. So we can just kill that one off. Let's see, maybe that will be enough to run this one. And at this stage, we showed you how to bake the trained model, but we've already baked a trained model, and it's sitting there, and now I just have to go grab it. G4G demo, neural network 1. And then auth. And again, we're going to reuse these credentials for Earth Engine and always set the project and make sure the project is registered as well. And now, here's the trained model. All of y'all should have access to this already. So we don't have to wait for the previous one to finish. That's where I got that thing. I just ran it previously. And we can check that we're able to load it. And then it's the same process as before. And again, this is just boilerplate code here. So we loaded the trained model, and now we're wrapping it in these deserialization classes. And we can have a look at that the updated model here. And it's expecting these named inputs, which is nice. And then we save it, hopefully.
It's going to take some time.
Okay, now this part should all look quite familiar to those folks who are in Neural Networks 1. It's basically the same thing. You just upload the model, and we'll see if I already have this model here. It might give me an error if I already have the same model. Yeah, you see. So we can just delete it. I'm going to just delete the old ones here. So Vertex, model registry. Oh, I guess I could just rename it too. Let's just try that. I'm just going to rename it. So sorry for the scrolling. Model name, model. How about model foo? Why not? And now we can do the same thing, hopefully. So basically, we're kind of bouncing back and forth between Colab and the Cloud Console here to just sort of keep track of what's going on. And there's a bunch of good monitoring tools in there. Not only the charts and graphs that Genna and I showed you, but all kinds of billing stuff and custom metrics that you can use to wrap your Earth Engine functions. And at this point, it's going to create an endpoint, and it's going to deploy the model to that endpoint ID. And we can connect to it from Earth Engine. And here's where I'm doing this trick of just injecting the stuff into an Earth Engine JavaScript script via these URL parameters. And so let me just sort of, I'm going to fake it for now because this thing is still running and I am running out of time and I want to show you how this works. So I'm actually going to stop deploying this thing. So it's not going to work, but that's okay. And just get this endpoint ID and I'm going to slap that in here. And then I'm going to slap my project in here. And then if you run this thing, it'll give you this link, and you go to the link, and it's not going to work for me because I killed the deployment. But you'll see that it creates this endpoint path, and then we'll attempt to connect, and it's going to get an error because we never finished deploying the model because I'm running out of time. But that's sort of the complete picture there. Maybe I'll just finish doing this for fun.
One quick comment about these sessions, what you saw. So one way to fix this, if you really need to run multiple notebooks, is, of course, the Colab Pro. That's one option. But another option could be is to, instead of doing this development in Colab, you can do this development in Vertex AI. There is a Colab Enterprise or what's called Workbench, where you could organize your Python notebooks together with your project. So usually it's handy, but that's gonna cost like extra some cents, dollars. I'm not sure what costs are, but that's alternative way. So for production projects, that would be more recommended way.
Okay, so somehow I had a deployed model on that endpoint already that's working, and here it is. You can see the predictions. Here's the connection to it. And again, it's this path. All you need to know is the project, the region, the endpoint ID, the tile size. This is like the part of the tile that you can see. Then it's going to slap 32 pixels on every side of it. So it's going to be, in fact, 128 by 128, but it's going to chop off 32 pixels at the edge of each patch. And that can help to reduce edge effects. And then it's just model.predictImage, and that's it. So that, this thing came from generating the training data via the Beam pipeline, training the model on Vertex AI, hosting it, connecting to it, and now we get our predictions. And this, unlike the demo that we gave you this morning, this should work for very large data sets and very large models. So that was the punchline of all this stuff. I have 1 minute left. And in my final minute, we did all this, we did all that. Oh, you can also do classification models. So patch comes in and pixel comes out. Here we had patch comes in, patch comes out. Here's patch comes in, one number comes out, and this was a beaver model, beaver habitat model. You can read all about it here. The code is there. There's the publication. We have lots of docs for all this stuff, including this tree crown segmentation thing that may or may not meet your needs, TensorFlow decision forests, and other variants of the same things that we showed you today in our docs. Also, shout out to Agave and our colleague David Cavazos, who put together these incredible People, Planet, and AI examples. And inside here, you'll find all kinds of even more fancy Dataflow stuff for generating really large data sets and that kind of thing. See these examples. We're out of time. Thank you very much. Can we take questions, or do we have to get out? We can take a question, how about? Any questions?
be safe, what things do we have to delete right now?
The question is, what do you have to delete? Go through Vertex AI, delete all data sets, all models, undeploy models from endpoints, delete all endpoints, go to cloud storage, delete all buckets. There's a Dataflow thing happening now, so you got to go to Dataflow.
Dataflow pipelines.
Delete all pipelines, delete all everything, and then you should be good. And if not, see me, I've got some cloud credits for you. Terraform, I don't know.
Yeah, so this step, what you saw here, I believe that we did not do this, but I believe that all these steps is just provisioning machines and pipelines, and then it should be doable with Terraform. Like to spin, especially this setting up all these roles and different services, that would be the good way. We did not test, I'm not sure, Jeremy can correct me, if we tested Terraform scripts working with Earth Engine, setting roles or other things. So that's something which not done before. Yeah, so that's what Terraform is designed for. We would be very interested, like if you would test this and see there will be any showstoppers, let us know.
In my region, for example, there is no one data center. By setting the multiple regions, it really works for me or not?
Multiple regions,
Yeah, I mean,
yeah, okay.
I would just choose a single region if you can, and don't use multi-regional buckets. My understanding is that all the Vertex AI stuff is regional, and multi-regional anything is not supported in there. So use regional buckets. Sorry, what was it? Could you repeat the question?
Yeah. I'm just wondering if I try to use a transformer model, if Vertex is able to run it using the...
A what kind of model?
Transformer models.
Oh, a transformer
Yeah, so we're
model.
actually trying to create some examples for this, so we don't have examples. I believe this fully convolutional neural network, it's like creating from scratch. With transformers-based model segmentation, they usually expect like RGB images only, so you cannot put like 8 bands. But we have, I'm not sure if we have this session, there is a segment anything model which we try to put over data flow pipelines at least. But I believe it would work in this way. So there's no difference what is running under Vertex AI. So it can be any of your fancy model.
Yeah, the short answer is yes. And what you want to do, I guess I need the notebook to show that part, is that instead of this, you could get your model directly from transformers. Does that make sense? Are you talking about the transformers package?
No, I'm talking about the default transformer model.
If there is a container that can run those ops, yes. If not, you have to make your own container that has all the stuff you need installed to be able to do that. And there's actually, I'm not sure if we have an example for that, but we should. Excellent suggestion, thank you. We'll work on a custom container example.